Good evening, physical science. This is our third week for notes online. And this week we're going to be talking about phase changes, energy level, and density. So when we come back from Labor Day, you actually have Tuesday, until Tuesday to do the notes because we're out Monday for Labor Day. So when we come back, we're going to be talking about how phase changes, which you guys talked about on Tuesday with Mr. Golden, how those are affected by energy level and how they affect density. So density and energy level are going to be different depending on what state of matter we're talking about. Now today we are going to still take our notes in Cornell note fashion, but I also want to tell you that you only need to write down the words that are in orange, or it may look yellow on your computer. But there are going to be some words that are gray, but we don't need to write those down because most of them are just questions for you to think about as you go through the notes today. All right. So our first question is, what happens to the energy level of the particles between solid and liquid? So this should be a review question. We talked about what the particles do in each state of matter. So what happens to the energy level between solid and liquid? Increase, decrease, stay the same? All right, hopefully you said that the particles get more energy as they become a liquid, and that's actually what causes them to become a liquid. So you have solid particles, and when they get warmer, they start to move around more, and that's what we think of as melting. So it goes from solid to liquid because the particles are warmer and they have more energy. So now that we remember that, let's take it a step further. What happens to the density of the particles between solid and liquid? Now, this is something we haven't talked about before, but I still want you to think about solids and liquids. Think about their properties. What do you think the density level does? Does density increase? Does the density decrease, or does it stay the same? Okay, so before we answer that question, let's remember that density equals mass divided by volume. So we're going to be looking at the volume of different things because we know that's the part that changes, right? Solid has a fixed volume. Liquid has a fixed volume. And gas does not have a fixed volume. So we're going to be looking to see how that changes as we go to each state of matter. Okay, so if we're looking at the mass and the volume of a solid versus a liquid, let's look at water, okay? 100 grams of water, or H2O, is the mass. We measure mass in grams. And that's going to be, it's going to have 100 grams of particles, whether it's a solid or a liquid, okay? So when ice melts, no other particles come in during that process. The particles that you started with are the particles that you end with. All right, so the thing that changes between solid and liquid is the volume. So let's think about it. Which one takes up more space, solid H2O or liquid H2O? Okay, so ice or water, which one takes up more space generally? Okay, so liquid H2O should take up more space than solid. And if you're thinking of an example and it doesn't fit, hold on till the end because we're going to talk about an exception to the rule, okay? But in general, when we're talking about solids and liquids, the liquids are going to move more freely, right? We know the particles move more freely than solid, and so they're going to take up more space as they change from solid to liquid. So that means that the volume will be greater in a liquid than a solid. Okay? Now, let's see if we can work out a problem that shows us this. All right? So if we have 100 grams of ice and it has a volume of 90 centimeters cubed, what will the density be? All right, so we have our density formula. Density equals mass divided by volume. So we divide 100 grams by 90 centimeters cubed. We use centimeters cubed because ice is a solid. And that should give us 1.11 grams per centimeter cubed. Okay? Now, let's look at liquid water. Let's say 100 grams of water has a volume of 100 mLs. What is the density? Okay? 100 grams divided by 100 milliliters is 1 gram per milliliter. And we know that liquid water does have a density of 1 gram per milliliter. So that means that liquid water, liquid H2O, has the higher density. All right? So I'm sorry, I should have said liquid H2O has the lower density, not the higher density. So it has a higher volume and a lower density. All right, so now that we've seen it between a solid and a liquid, let's think about which one would take up more space, liquid or gas. Okay, liquid or gas. So we know solid takes up less space than liquid. So which one takes up more space, liquid or gas? Okay, you should have said that gas takes up more space, right? If we spray some perfume in the air, it can spread throughout the whole room, whereas a liquid cannot do that. So let's check our math using liquid and gas now. Let's make sure it still works between liquid and gas, since it does work between solid and liquid. So if we have 100 grams of liquid gold, and it has a volume of 6.5 milliliters, that would be 100 divided by 6.5, which would give us a density of 15.4 grams per milliliter. So that's liquid gold. All right. If we were to do the density of gaseous gold, or gold in the gas form, we do 100 grams of gaseous gold. Now it has a volume of 7.2 milliliters. So when it became a gas, it spread out a little more. It took up more space. That's why our volume is bigger. 100 divided by 7.2 gives us a density of 13.8 grams per milliliter. So again, we saw that solid had a greater density than liquid, because the liquid took up more space than the solid did. And now we see that liquid has a greater density than gas, because gas takes up more space than liquid does. So going from solid to liquid to gas, the density should decrease. All right. Now this is why gas floats on liquids and liquids float on solids. So let's think about a lake. Okay, lakes are liquid. At the bottom of the lake, if we drop things in the lake and they have a greater density than water, then they're going to sink. So let's say we have a boat that sinks. The boat is going to be at the bottom of the lake. It is a solid. Then we have the water from the lake, which is a liquid. And then on top of the water, we have the air that we breathe, right? So when we swim in the lake and go underwater, we have to come up for air. We don't swim down to get to the air. That's because the air is less dense, so it stays on top of the water. All right? And if we throw something in the water and we need to go get it and it doesn't float, we're going to have to swim down, because it is going to sink to the bottom, because it probably has a density greater than water. Okay? So going back to our energy levels, don't forget that as particles warm up, they move faster, which means they have more energy. That's what causes them to change state of matter. So if we have a solid and it gets heated and the particles move faster, it will probably become a liquid, and we call that melting. And if we take the liquid and we heat the particles up, it's going to become a gas, because the particles are going to move so fast that they start spreading out and they become less dense. And so that is from liquid to gas. We call that vaporization. So all of what you've been learning about state of matter and phase changes works together. And that's what we're going to spend all of next week making sure that we really understand. And we're going to do some lab experiments and stuff like that to see what we're talking about. Now, I told you there was an exception to the rule. And so some of you might have been thinking about water and ice, and you might have said, wait a minute, if ice has a higher density than water, why does it float? Like if I put ice in my drink, it floats. It doesn't sink. All right. If it was more dense, wouldn't it sink to the bottom? All right. So water and ice are a little bit of a different story because ice particles actually form a crystalline shape, which means they kind of have like a crystal looking appearance. All right. Now remember we looked on our simulator in class, we saw that the H2O molecules kind of made a little curved shape, kind of like Mickey Mouse or a teddy bear, whereas other molecules were small and just lined up right next to each other. So if you look at the bottom here, you'll see ice is in the red and white picture, and the ice molecules form this crystal lattice, but it actually has a lot of space in between each molecule of H2O. If you look on the other side, the blue solid, where it says most solids are really compact and the particles sit right next to each other. So when we have ice, actually it has a lot of gas in between the solid molecules, which means that actually, even though we calculated our problem as if ice was more dense than water, ice actually is less dense than liquid water because all of that air is trapped in between the molecules, and so its overall density is less than it is in the liquid form. So it's kind of a little exception to the rule, but in general, solids are more dense than liquids, and liquids are more dense than gases. So make sure you have these notes in class on Tuesday. Make sure you let us know if you have any questions or put them on the question parking lot. See you later. Bye.